Goyal Brothers Prakashan welcomes all the participants in the webinar. We are happy to introduce Goyal Brothers Prakashan as one of the leading educational publishing house in India. For more than 6 decades, we have been engaged in the educational publishing and educational technology business. We publish all types of educational books for the K to 12 level in the different subjects for CBSE, ICSE, and different state boards of India. The company has been selling about 10 million books every year in more than 25,000 schools in India and abroad. Goyal Brothers Prakashan has been conducting seminars, workshops, and webinars for principals, teachers, educationists, students, and parents on various educational and non educational topics like changing syllabus exam pattern, career guidance, parenting, pedagogy, coding classes, usage of technology, cybersecurity, general awareness program, and many more. We have conducted many hundreds of webinars with about 1 million participants in the last 3 years. The technology arm of Goyal Brothers, Prakashan, Right Duty provides online digital learning content for the K to 12 level in a variety of languages for more than 20 educational boards in all of the major subjects. Today we have Mr. Shaurya with us, who is having more than 10 years of experience in the industry as well as the author and editor. Over to you, Shaurya sir.
Thank you, Vaishali. Good evening, dear teachers, all the students who are present. I welcome you all on the behalf of Goyal Brothers Prakashan on this webinar where we intend to discuss the latest changes in the ISC paper curriculum. Okay, so firstly, I'll just run down quickly to the flow of this webinar. Firstly, we'll discuss about the conduct of examination for the term 2. We'll in detail discuss the bifurcated and the reduced, rather the further reduced syllabus we have at our hand. We next lay our hands to specimen question paper shortly released by the board. Later, we intend to discuss how to guide our students to prepare well for this forthcoming examinations. In the end, we'd conclude by how this question bank plus model test paper released by Goyal Brothers Prakashan would be an aid to students as well as teachers in this preparation. At the end, I would like to take any questions, doubts, suggestions are most welcome. Okay, so to begin with, we obviously had a lot of doubt about the conduct of term 2 examinations, but with the 14th February notice released by the Council of Indian School Certificate Examination or ISC, it's clear that the examinations for class 12th term 2 will be beginning in the last month of April. Most probably it will carry on for the entire month of May. Further, the exact timetable or the schedule is to be released or expected shortly. Now, what we have at our hand from this, or rather from the last year, the entire syllabus or the structure of our annual board examination was broken down into 2 terms. Now we are already done with the term 1 MCQ based examinations. Even the results were out like a couple of months before. So at this point here itself, all the students who are here, please do not get disheartened with whatever marks less or more you attained in your term 1. There's a lot more, rather precisely 50% more to work on from here on, and we have good sufficient like 70 days time at our hand. Now our entire course structure of 100 marks, which initially included 70 marks theory plus a 30-mark practical weightage, was split into 2 terms, where the theoretical portion was 35 marks in both the terms and the internal assessment or the practical was 15 in either term. Now, broadly, our class 12th physics syllabus have 9 units, out of which we have covered the first 5 units in semester 1. So I'll not be talking about those units starting from electrostatics till electromagnetic waves. What we have at our hand in semester 2 is 4 units. I'll take some time to discuss in detail what are the omitted topics, discussing it chapter by chapter and topic to topic. So let us begin with the first unit which we have in term 2 syllabus, that is optics. Now, in our unit C, I have been referring to a particular book for the ISC curriculum where we have the optics, which is further split into ray optics and wave optics, as we know. Now, ray optics consists of 5 chapters that used to be reflection of light, refraction through plane surfaces plus the total internal reflection. Next, it was followed up by refraction through curved surfaces and lenses. The later chapter dealt with refraction and dispersion by prism as well as scattering. And the last chapter in ray optics was on optical instruments, where we discussed about microscopes and telescopes. Also, we had a small topic of resolving power in this. Now, under the wave optics, what we had was Huygens principle, interference of light, diffraction, and polarization. So I'll not just read down to this. Let me just move ahead. Now, these are precisely the chapters which are in red color. These entire chapters have been deleted from our term 2 syllabus. So students and teachers, I guess this should be very clear. Under ray optics, the entire first two chapter that deals with reflection of light and refraction at plane surfaces, including total internal reflection. This has been totally omitted. A chapter under wave optics, that is polarization, has been totally wiped off. Under the next unit, that is unit 7, dual nature of radiation matter, the third chapter which we had in the name of X-rays have been totally deleted. Jumping to our next unit 8, radioactivity has been completely removed from the syllabus. As for in the books, obviously still now features a unit 10, which I earlier did not mention since it's nowhere there in the last two-year curriculum. So the entire 10th unit, that is communication systems, we used to deal with AM, FM, optical fibers and all that, has been completely chucked off the syllabus. Okay, now I'll take turn to go unit by unit. So first starting with optics. Now, I guess there's clarity here, like these are the name of the chapters that has been totally deleted. Now, all the remaining chapters, there are some topics or portions which are to be left out. So starting with optics, these are what we are left at hand, right? After the deletion of first two chapters of reflection and refraction at plane surfaces and polarization, we are left with 6 chapters. Now, among these 6 chapters, these are the precise deleted topics. So I'll take them one by one. In the first chapter, that is refraction at curved surfaces. Now there's a derivation that is before the lens maker formula that relates the n2 by v minus n by n1 by u is equal to, that is relating the u, v, r1, r2. Now for that, only one derivation has to be done by the students. That is refraction at concave spherical surfaces. That means concave spherical surfaces have been removed. Only the derivation for the same with the convex spherical surfaces when light moves from a rarer to a denser medium. That means the convex surface is focusing or is towards the rarer medium. Only that derivation has to be done with the students. I hope this point is clear. I'll again repeat it. The refraction derivation for relating the refractive index of both the mediums and the radius of curvatures of either surfaces, we only need to stick to the convex spherical surface, not the concave one. Similarly, under the derivation for the magnification, only it's need to be done for the biconvex lens. Again, the concave lens derivation can be left out. In the next chapter, that is refraction and dispersion by prism, the entire first part of the chapter that deals with the dispersion of prism, dispersive power, the important graph between the angle of deviation and angle of incidence, that is very much there in the syllabus. The later part of the chapter, that was scattering and all the related phenomena, firstly where we read about some idea about the Rayleigh scattering and the related phenomena like why does the sky look blue or the clouds white, or for example why does the sun appear orangish during the sunrise and sunset. All these later parts related to scattering and its phenomena have been wiped off. Jumping to the last chapter of ray optics, that is optical instruments, there is a very specific deduction what we have. The derivation for the magnifying power of the compound microscope when the image is formed at infinity has been removed. I hope everyone is clear, like we read dual cases for all the optical instruments where the final image is produced at D, that being the least distance of distinct vision, 25 centimeters, and the other one for the relaxed eye, that was when the image is formed at infinity. So this particular derivation for magnifying power of a compound microscope when the final image is formed at infinity has been removed, although we can definitely have numerical based on this because the derivation has been chucked off, but the formula as it is very much there in the syllabus. Further, the last part of this optical instruments chapter that deals with the resolving power of the optical instruments has been totally removed. So we can skip that one. Now coming to wave optics under this unit. In the Huygens principle, most of the books do not even cover this topic. Still, since we should know, the refraction through prism and lenses have been removed. So what mostly is left in this chapter is starting with what is the concept of wavefront, the Huygens principle, besides the most important two derivations, that is proof of reflection and the refraction, right? The laws of reflection and refraction via Huygens principle is very much in the syllabus. Under the interference, the one long derivation what we have, like for the two progressive waves moving in one direction, when we take one of the waves to be, let's say, y is equal to a sine omega t minus kx, and the another one a sine kx minus omega t plus phi, that's some phase difference. This entire derivation has been removed. So the mathematical deduction has been result. Obviously, the result is very important. What we end up with, like I is equal to I1 plus I2 plus 2 root I1 I2 cos phi. That is there, and we can definitely expect numericals on the same. Okay. Coming to diffraction, it's obviously the shortest chapter what we have at our hands, and none of the topics under that have been deleted. So I hope there is clarity about the first unit, optics. I am laying so much emphasis on this because we'll later see that it is about to cover like 50% of the paper we are expected to have in our term 2.
Now, subscribe to Bright Duty course at rupees 1 per day only. Download Bright Duty app from Play Store and get the online courses prepared by competent and experienced teachers for different education boards of classes 6 to 10. Bright Duty courses are available for the subjects of Math, Science, Social Science, English and Hindi in English and Hindi medium. Bright Duty follows three-step approach, that is learning, assessment and exam preparation. In learning, topic-wise video lectures with explanation of concepts and discussion of textbook examples and questions are available with the solutions. In assessment, topic-wise online MCQ test, practice assignments and chapter-wise question bank are available with the solutions. In exam preparation, previous year's question papers, sample papers and model test papers are available with the solutions. Sign up today on Bright Tuesday and avail your courses at affordable prices.
Okay, now coming to our next unit 7, that is dual nature of matter and radiation, which after deleting the X-ray chapter, we are left with two chapters, that is photoelectric effect and matter waves, dealing with de Broglie's hypothesis. So under this, the photoelectric effect, none of the topics have been deleted. Under matter waves, the electron diffraction, or rather what I can say, Davison-Zermer experiment has been left out. But I will suggest teachers just to brief them about this, because the qualitative part of this has been included in the syllabus. If you would have seen that, electron diffraction and the qualitative aspect is still there. So among the Davison-Zermer experiment, what we use the Bragg's law and the hypothesis by de Broglie to understand कि for a given accelerating potential of 50-volt, why there is a certain preferential angle of diffraction of electrons, that all mathematical aspect have been left out from this. More or less, the rest of the chapter is very much there. Now, the next unit, what we have is atoms and nuclei. It initially used to have 5 chapters, among which, as we earlier discussed, radioactivity has been left out. So it's a relief for students, I guess, because we were definitely going to have numericals coming from that. Now, among these 4 chapters, most part of it, I would say the entire unit is very much there. Only the last chapter, which deals with nuclear fission, fusion, and the nuclear reactor, all the nuclear holocaust, all that. The very end part, that under nuclear fusion, the details of the proton-proton cycle in a star, that is when 4 protons or 4 hydrogen atoms gets converted to helium, the student must be aware with the final reaction what we have at our hand. But all the intermediate steps, like 2 hydrogen converting into a deuteron, then a helium-3 converting, combining with a helium-2, all that have been erased. Besides that, we have an additional carbon cycle also given in most of the books under nuclear fusion as a part of chain reactions going on in any star in our universe. So the entire carbon cycle reactions also have been checked out. And coming to our last unit, that is electronic devices, we were left with a couple of chapters there that deals with semiconductor electronics and junction diodes. Now, the first chapter is very much remains intact. None of the part on this semiconductor electronics chapter has been removed. So here we need to properly understand the classification of materials into conductors, insulators, and semiconductors based on the energy band theory, right? That is important, based on the energy band theory. Besides that, in the junction diodes, the diode to be used as a rectifier, the half wave and the full wave rectifier is there. Under the full wave rectifier, we will not be reading the bridge rectifier. That is using 4 diodes to be used in a rectifier. So we'll only be left within a full wave rectifier as a center tapped rectifier, just using 2 diodes and a center tap transformer. Now, among the various types of diodes we were to study in this chapters like photocells, solar cells, and LED, and the most important being Zener diodes, since it included circuits and numericals. This entire part of Zener diode and all its associated IV characteristics and numericals have been removed. So this now mostly boils down to a theoretical subject with some importance on the IV characteristics of the PN junction and forward and reverse bias. So I hope this is clear, like what is to be read and what is to be left out. Please do not waste any time reading the deleted topics. We for sure will not be having any questions coming out from these topics. Next, as for the practical or the internal assessment, in physics, what we have is we have already, I guess, all the teachers have assigned a practical, which could be a working model, it could be a theoretical project. So we have already assigned 10 marks. The board has already clearly specified the 10 marks will be for the project work, whatever the student gives as a write-up or shows as a descriptive or a working model. Further, all the work they have done internally, the experiments that have been done by the students, which in term 2 have just 2 broad categories. We can have experiments either from semiconductor physics or from optics. These are the 2 broad criteria, right? Sorry, the 2 broad domains from which we are expected to do our experiments. So I'll just suggest your student must at least have record or practical notebook with at least 4 experiments for term 2 separately. So this term 2 will definitely be evaluated besides the internal faculty of the school by an external examiner allotted by the board. So now it will not be a school affair. So I'll suggest all the students to take it seriously that you must properly prepare your project work file or as well as your practical record of the experiments we have already done. Now, recently we had a specimen question paper for term 2. We'll discuss this in greater detail. There are just some snapshots from 3 sections of the paper. The entire paper is divided into. You can also have a direct link for the physics term 2 paper uploaded on the official website of CISCE. Now, the format of the question paper is such. As we already know, the remaining 35 marks is the total weightage, and the allotted time is 90 minutes as the writing time. Now, as we in the previous term had about 20 minutes of reading time, in this particular term, the reading time is 10 minutes, in which a student is not expected to write anything. So this 10 minutes is surely the reading time. We'll later talk about it, what can be done in this 10 minutes to utilize it to its maximum. As I've already conveyed, the entire writing time or the entire paper's time is just 1.5 hours or 90 minutes. Now, total number of questions what we had in the specimen question paper were 22, out of which 18 were to be attempted. Now, this paper has a broad segregation into 3 sections. Section A comprises of 7 marks, B of 10 marks, and last section C of the remaining 18 marks. Now, what we have in section is 7 questions, all of 1 mark each. Among them, the first 3 are to be a very short subjective questions, simple 1 or 2 line answer type questions. The next 4 questions to follow in section A are multiple choice questions with 4 options each, out of which only 1 option could be correct. Now we do not have any option as in section A, like all the 7 questions have to be attempted by a respective student. Coming to section B, it comprises of 5 short type subjective questions, that is 2 marks each. That will make it 5 into 2, 10 marks weightage for this section B. Now, among these 5 questions, we have in total 7 questions, but there is no overall choice that out of 7 questions, 5 have to be done. we only have internal choice in 2 questions. That means out of the 5 questions, 3 becomes mandatory to attempt without any options. Among 2 questions, we have internal choices. But one thing to note here is that even if a question has internal choice, it is for sure that it will be from a same topic. For example, if a particular question has 2 choices and both of them must be from the unit nuclei only, we cannot have one of them from optics and another one from nuclei. I hope it's clear. Now, the final section C has 5 long questions. When I say long, like relatively longer than the previous section, because they are still 3 marks question. None of the questions are supposed to be 5 marks. So we have 5 long questions. Now, among these, we have 4 questions that are normal question 3, and which we have internal choices still in 2 questions. Besides that, there is a one subjective case-based study this time. So there will be a small paragraph. So this is not a separate unit. Among the sections we, out of the 5 questions we had, one among them only is a case-based study in which we'll have 3 questions, which will not be multiple choice questions like before we are used to. So this is a subjective case-based study type question. So there's one case-based study will follow up with 3 one-marker questions under that, which will be small subjective answers, no MCQs. Okay, so I'll just again repeat the section C for clarity. As I said, among the 5 questions, there's one case-based study, and remaining 4 questions may say we have internal choices in 2 of the remaining questions. Okay, so case-based has to be attempted, cannot be left out. Besides that, 2 questions are mandatory, and in the remaining 2 questions of 3 marks, we have internal choices among which we can pick. Again, the pattern remains same as in section B. Even if a question has an internal choice, it will definitely be from the same topic, right? So this is the format to which I guess the board will stick when it comes to the final paper for term 2 physics.
Now, subscribe to Bright Duty course at rupees 1 per day only. Download Bright Duty app from Play Store and get the online courses prepared by competent and experienced teachers for different education boards of classes 6 to 10. Bright Duty courses are available for the subjects of Math, Science, Social Science, English and Hindi in English and Hindi medium. Bright Duty follows 3-step approach, that is learning, assessment and exam preparation. In learning, topic-wise video lectures with explanation of concepts and discussion of textbook examples and questions are available with the solutions. In assessment, topic-wise online MCQ test, practice assignments and chapter-wise question bank are available with the solutions. In exam preparation, previous year's question papers, sample papers and model test papers are available with the solutions. Sign up today on Bright Tuesday and avail your courses at affordable prices.
Now, here are some analysis on this paper. Now, as you can see, a triple bar graph representing each unit on optics, dual nature of matter and radiation, atoms and nuclei and semiconductor. All these yellow bars stand for the 1 marker questions. The adjacent greenish turquoise blue line or the bar stands for 2 marker questions from that unit. And lastly, the purple stands for a 3 mark question, which also includes the case-based study coming from section C. Now we can definitely see some high peaks roaring in optics, right? So we have around 3 1 marker questions from optics, 3 again 2 marker of section B questions from optics, and again 3 questions coming from part 3, that is section C. Among the second unit or the 7th unit, as I should say, that was dual nature and radiation, we only have 2 1 marker question and 1 2 mark question which got featured in the specimen question paper. There was no question or 3 marks coming from this particular unit of dual nature of matter and radiation, which includes both the chapters, right? Photoelectric effect and matter waves. The next unit, being atoms and nuclei, does not feature any 2 marker question from there. What we expected to see is 2 3 marker question or section C questions coming from this unit with 1 1 marker question of section A. Now, as for the last unit, that is semiconductor, we have 1 1 questions in each of the sections. So 1 1 marker question, 1 2 marker question, and 1 3-marker question that we are expected to have from the last unit of semiconductor physics. Okay. Besides that, I've made couple of pie charts. Now, the first one says the unit-wise weightage. Now, obviously, there is a huge share captured by the first unit being optics. That obviously includes the first 5-6 chapters from ray as well as wave optics. So you have this at your hand, right? This is the majority where we need to focus on. 52% means like around 18% out of your 35 marks is just coming out from this particular unit, optics. Remaining 20% from atoms and nuclei, 11% from dual nature of matter, and lastly 17% is being featured from the last unit, semiconductor. Now, I also tried to segregate the questions on the type. What I've done, like when I say theory, I mean these were like straightforward questions like definitions, more like something a kid needs to remember or mark up. Next, the derivations and the numericals respectively were 9% and 23% of the entire paper, which in marks would be around just 3 marks and 6 to 8 marks of derivations and numericals respectively. A very small percent of questions were conceptual, mostly based on the graphs coming up from the photoelectric effect. Now, besides this, what we need to do to prepare our students, or how do we motivate, or how do we give them a proper direction to prepare for this term 2 examination? Now, what I personally feel, our students lack the practice of writing for 1.5 to 2 hours, right? I hope you'll all agree with me. Given past 2-year format, mostly dealing with multiple choice questions that they just needed to take, no subjective answers, no working to be shown, was an easier task, I could say. So students, please take note of this. Please, like give decent amount of time on writing things. Okay, just do not still be done with like reading through the pages. Just practice a particular topic. If you memorize something like a particular derivation, just practice it again and again. Now, these are some broad areas we can focus on. Firstly, when it comes to numerical, although it had a very less share of the entire paper, still there is a very limited domain from where we can expect our numericals to be. First, definitely is optics. We can definitely expect 2 to 3 numericals from optics, which could either be from optical instruments directly relating to the formula of the magnifying power. We can have a question as easy as the level of class 10th. An object is kept here, where would the image be formed and what would be the nature of the image? So optics is definitely an area where we need to help kids with some numerical practice. Besides that, I'll say all the other topics just have a very limited scope of numericals to come from. They are very straightforward as it comes to photoelectric effective formulas or the hydrogen line spectra, de Broglie's hypothesis, and finally binding energy. So I would say you do not have much purview to choose from. These are simple topics, I would say. If we relate it to our term 1 syllabus, I would definitely say this term 2 is a easier way or is a lesser syllabus to prepare ourselves. Now, coming to derivation, which we might expect are definitely the lens maker formula, the refraction through curved surfaces, even the the dispersion through prism, where we find the refractive index of the prism or relate the angle of deviation to the angle of incidence I plus E minus A angle of prism. Besides that, we have optical instruments ki magnifying power. That definitely can be a derivation which can be asked. Lastly, I would say we have some derivations arriving from the Bose model of an atom. It could be like find the total energy of an electron in a given shell. It could be how is radius related to velocity of an electron, anything from that Bohr particular topic. So this, we might have a very direct question or it might be an indirect question. So I would suggest, at least for this particular topic of Bohr's model of atom, please study this in proper detail, as in from where does this all the derivation come from. Next, when it comes to some diagram practice, obviously the most important topic here too will be optical instrument. Now, if you have practiced it enough, it's okay. But even we must have encountered this ourselves as teachers and students. Let's say, for example, I have been given to do a derivation for magnifying power of a compound microscope. Now, if we all know what is a compound microscope, right? Two convex lenses, one small, one big. But if we draw wrong rays, then we might really get stuck in deriving a lens maker formula, for example. So I would ask the students to rigorously practice these derivations along with the diagrams. Okay. Now you need to be so fluent ki wahan you need not think. It should be like write and go. You should not be wasting any time over these derivations. You should have at least practiced each of them. I would say at least 5 to 6 times. More the merrier, obviously. Now, as the last part of questions where you can expect some tough small questions, maybe 1 or 2 marker, could be from graphs. That is, we have different plots in the photoelectric effect. Let it be how does the frequency vary with the intensity, or how does the stopping potential vary with the frequency. We could have like 3 to 4 different graphs. The student must not be confused among this. You should have complete clarity among all these graphs pertaining to this particular topic of photoelectric effect. Besides this, among graphs, I would say the IV characteristics of the PN junction diode in forward and reverse bias also happens to be an important topic. So, students, overall, my advice will be write more and more. Just do not flip your pages ki ek baar padh ke aa gaya. It's better we write the things which are expected to come, and definitely this optical instruments, as we already saw, like 50% se zyada is only optics. So you could precisely lay all your attention primarily to the derivations and the diagrams of this lens maker formula and the other derivations we have in this unit of optics. Now, how does the question bank published by Goyal Brothers Prakashan aid in this preparation? This question bank has a chapter-wise summary that would be a 1 or 2 page summary to start, which would include all the important endpoints, maybe the graphs, the figure of PN junction, whatever is really relevant in that chapter. We follow it up with a solved specimen question paper released by the board. To add to that, there are 5 unsolved model test papers on the exact scheme and the weightage as given in the specimen question paper. So these model test papers, we can leave it for the later part of our preparation. And I'll advise students to please take this model test papers as a time-bound test even at your home. Okay, it's not like कि घूमते फिरते हुए अभी 2 question बाद में वो. Please time it like we have only 90 minutes, and then try and see or evaluate yourself where are we standing and which particular domain needs more or greater practice from you. Now I've already given a link out here, which is a flip book. So this book, flip book, can be like dealt online. It's like simply flipping the book. It's like more like real book. So it can be aid to teachers and students as well. Now this is what all I had to convey from my end. Now, if at all there are any doubts, suggestions, or if you like to suggest something more that needs to be conveyed to the students, I'll be more than welcome to take them out.
So we welcome all the questions now. Anyone who has the question can either write in the chat box.
Good evening, sir.
Good evening, ma'am.
Sir, this is Saranya from Primrose, Pondicherry.
Lovely to hear from you. Please go ahead.
Sir, I have a doubt regarding the reduced syllabus.
Please, ma'am.
Semiconductors, you have mentioned about the bridge rectifier, but
Yes.
As far as I've seen, they have mentioned about the full rectifier and the half rectifier in the reduced syllabus. So
I'll just lay some light on this, ma'am. I already conveyed both the half wave rectifier and the full wave rectifier in the syllabus. But among the full wave rectifier, we only teach the one using 2 diodes. Now, bridge rectifier is a circuit which uses 4 diodes. That has been left out. So, full wave rectifier using 2 diodes and a center tap transformer is very much there in the syllabus.
okay, thank you, sir. So, and one more doubt I have.
Sure.
Yeah, there are some derivations where we have, like, it will be usually asked in a 5-mark question. For example, the lens makers. So how will they ask the same question in 3 mark, or is there any possibility like that?
Ma'am, we might have it as a 3-marker question only, although I understand it used to be a 5-marker question, the entire derivation. But yeah, now since there are no 5-mark questions, we may expect lens maker formula, or they just might ask us to reach the formula till a given step. Because ma'am, lens maker formula as such is not so big, because under that we'll not be deriving the first part of it, that n2 by v minus n1 by u is equal to n2 minus n1 by r. We need not derive this part of it. We'll straight away use this result twice on both the surfaces, and then we can directly bring it to the lens maker formula.
Okay, sir. Thank you, sir.
Most welcome.
Yes, sir. Good evening.
Good evening, sir.
This is Ranjit Sarkar from Jharkhand. I want to ask one question based on the optical instrument.
Please, sir.
Okay. In optical instruments, the last part in ray optics, the students have to learn. Students have to practice the telescope only for the ray diagrams.
So under telescopes, as such, we have not taught the kids the proper derivation. But yes, the broad magnifying power we know is FO by FE, and we can expect numericals. What might come from the telescopes is a direct question on please draw the ray diagram of a reflector telescope or a refractor telescope, as both of them are in the syllabus. And that might be followed with just write the magnifying power of a telescope. They will not be asked to derive it as such.
That means they have to learn the refracting telescope and reflecting telescope.
Yes, sir. Both the telescopes are there in the syllabus, the reflectors and the refractors as well.
Achha, in reflector, yes, in reflector that mirror used, that means only one type of reflector telescope they can write, or other mention that is specified.
Since you are asking this, we basically teach a class 12 student about a basic reflector. We have never graduated to higher designs like Cassegrain and all. So yeah, the basic diagram like a primary mirror and the rays being reflected on a secondary mirror and out to a convex lens. That is all.
Yes. So which one most important? That means they have specified, not specified any special telescope. So that's why I'm asking.
So there are two simple ray diagrams. If it comes to telescopes, the refractor, as we all know, is more like a binocular. One bigger convex lens towards the object and a smaller one towards the eyepiece. That is a simple ray diagram. It's very much similar to the compound microscope, just the opposite of it. When it comes to reflector, the one I just mentioned, like a simple hollow tube with a curved mirror and a plane mirror kept at a 45-degree angle, that particular ray diagram has to be taught to the students. There is no as such
and one lens also used, no?
Yes, sir. Once it gets reflected from the secondary mirror, that is a plain small mirror, it comes or protrudes out of the telescope tube onto a small eyepiece lens, again being a convex lens.
Yes, sir. That one basic they have to know.
Yeah, both of these are in syllabus. So yeah, students must be taught this.
Okay, thank you, sir.
Welcome, sir.
Any other doubts do we have? We have sent a link of the WhatsApp group. That is a common group for all the teachers for ISC. So all the content related to all the subjects will be sent there as well. So you can join the group for your convenience if you want to. As well as I sent the link for you to have a look at all the books for all the subjects. This is where you can buy all the subjects, books. Thank you for participating in this webinar. We hope you enjoyed the webinar with some useful takeaways. We would like to hear back from you. You can share your feedbacks or suggestions via our email ID that is displayed over here as well. That is marketing@goyal-books.com. Also, if you are looking for an opportunity to work with us in any capacity, like an author, resource person, subject expert, editor, reviewer, etc., kindly share your details in the same email ID. That is marketing@goyal-books.com. If you want us to conduct a webinar for your organization, kindly write us to at the same email ID. Goyal Brothers Prakashan, once again, thank you for participation in this webinar to make it useful. Thank you so much, everyone.
Now, subscribe to Bright Duty course at ₹1 per day only. Download Bright Duty app from Play Store and get the online courses prepared by competent and experienced teachers for different education boards of classes 6 to 10. Bright Duty courses are available for the subjects of Math, Science, Social Science, English and Hindi in English and Hindi medium. Bright Duty follows three-step approach, that is learning, assessment and exam preparation. In learning, topic-wise video lectures with explanation of concepts and discussion of textbook examples and questions are available with the solutions. In assessment, topic-wise online MCQ test, practice assignments and chapter-wise question bank are available with the solutions. In exam preparation, previous year's question papers, sample papers and model test papers are available with the solutions. Sign up today on Bright Tutor and avail your courses at affordable prices.